easy, but they're straightforward. Because a lot of the skills that you need for these, you've already learned. So a lot of function operations are just things like combining like terms, box method, things like that. Things that you've already learned how to do. All right, whether math 2, math 1, even 8th grade math. All right. Doesn't mean we're not going to go through it. All right. I'm not going to just say, have at it. No, we're going to talk about it. All right. So let's look at all the different operations that you will see. So first off, the very simple adding functions. All right. Now, for each of these examples, we're going to be using these two functions. So f of x, which is 3x plus 2, and g of x. Yeah, I am. And g of x, which is x squared minus 2x plus 10. Now, how you will see adding functions a lot is you would see something like this. So f plus g of x, which is the exact same thing as f of x plus g of x. All right, so if you see this notation right here, f plus g of x, it just means add the two functions together. So if I set this up, all right, so if I'm just adding f of x plus g of x, that means I'm just going to take whatever f of x is, bring it down, 3x plus 2, plus, and I'm going to bring down g of x, x squared minus 2x plus 10. So this is f of x. This is g of x. And then I am adding them. So let me ask you guys this. What do you think you're going to do to add these functions? Something you've already learned how to do. So if you're looking at something like this, what would be your first instinct to do? Combine like terms. All right, so adding functions is very easy. All you got to do is combine like terms. Now, can anyone remind me, someone who has not spoken yet, what like terms are? What describes a like term, Jaden?
Like 3x and 2x.
Right, so in other words, same variable, same exponent, if there is one. All right, so it has to have the same variable, same exponent. So Jaden said that a like term is 3x and negative 2x. That's correct. What's another set of like terms? Anyone? The 2 and the 10. Good. Now, even though the x squared is all by its lonesome, it's still important to kind of highlight it, just so that we know it's still there. Now, once we have our like terms, here's my question. When we combine like terms, what are the only thing that we are combining? So what's the only thing in like terms that we combine? Is it the numbers? Is it the variables? What are we combining? Not the variable. The only thing you add is the coefficients, which is the number in front of the variable. That's the only thing you add. So you would do 3 minus 2. You would do 2 plus 10. All right? And then whatever variable's after it, that's what you slap on at the end. All right? So, for example, and I'm going to rewrite this in standard form. Does anyone remember what standard form is? What does it mean to write a function in standard form? Right. So, just make a note. Standard form. I don't know why I wrote stand form, but, you know, it's one of those days, I guess. Standard form is just highest to lowest exponent. So you're going to write the highest to the lowest exponent. So what term would come first if I want the highest exponent?
X squared.
X squared. Now, since x squared doesn't have anything to combine, we're just going to bring it down. What comes next? What variables? The x's or the constants? The x's. So I'm just going to rewrite 3x minus 2x. And then my constant. So plus 2 plus 10. And then I'm going to combine these two and these two. So it'll be my final expression. So I bring down the x squared. What's 3x minus 2x? Not just 1x. Oh, yeah, it is 1x. So plus, you can either write a 1 or you can just write x. 2 plus 10? 12. And that's all there is to it. That's your new answer. Easy, right? It's just combining like terms. So remember, with like terms, whatever the term is, all you're doing is just adding the numbers in front of it, and then whatever number you get, slap on the variable at the end, if there is one. So if there's an x at the end of that term, slap on the x at the end. You're not actually combining the variables at all. So this, like if I add 3x minus 2x, it's not just 1. All right, because don't like erase the x's. It's 1x. All right, or let's say this was an x squared and I had another x squared. It's not 2x to the fourth, it's 2x squared. All right, you only start changing exponents when you start multiplying. All right, adding and subtracting, exponents and variables stay the same. Any questions? All right, subtracting functions. Subtracting functions, very, very similar to adding functions. You're still combining like terms. However, there is one thing you have to do first before you can combine like terms. Does anyone know what that is?
You change the signs.
Change the size of which one? The first function or the second function?
Second.
Second. All right. So, like Anna said, you would change the signs or flip the signs. In other words, we would distribute the negative first. And again, that's the same thing as just flip signs. Now, another thing to note is that when it comes to subtracting, order matters. Adding, it doesn't matter what order you put them in. So I could have put g of x before f of x from the previous problem first, and I would have gotten the exact same thing. But with subtraction, order does matter. So if they put f of x first, when you rewrite it, you got to put f of x first. If they put g of x first, you got to put g of x first. All right, so whatever order they give you. So, for example, they said f minus g of x. It's the same thing as f of x minus g of x. I have to write f of x first. All right, so I'm going to write 3x plus 2, that's f of x, minus, and I'm going to put parentheses, because remember, this minus applies to all of g of x squared minus 2x plus 10. So again, I put the second function in parentheses, because remember, all of this is g of x. And the negative is applied to all of g of x. All right, so the parentheses remind me of that fact. All right, because then, just like Anna said, we would have to take this negative and we're going to distribute it to all of the terms in g of x, or in the parentheses. And essentially, when we're distributing the negative, all we're doing is flipping the signs. So in other words, I would bring down 3x plus 2. That stays the same. If I have a positive x squared, what does it become if I change the sign? Negative x squared. If I have a negative 2x, what does it become? Positive 2x. If I have a positive 10, what does it become? Negative 10. Once I do that, it is business as usual, and you are combining like terms. So someone tell me one set of like terms. So 2 and negative 10. What else? 3x and 2x, and then negative x squared is just all by its own. I want to rewrite in standard form. So what color comes first? Blue, green, or yellow? Blue. So I'm going to write negative x squared. What comes next, green or yellow? Green comes next. So plus 3x plus 2x, which means the yellow comes last. So plus 2 minus 10. And then I combine where I have to combine. So again, I bring down the negative x squared. What's 3x plus 2x? 5x. So plus 5x. What's 2 minus 10? Negative 8. And I'm done. So, big takeaway from subtraction. Order matters. Order matters. If one function comes before the other, you've got to put that function before the other. So my recommendation, even if it's like something like adding or multiplying, which is commutative, meaning you can change the order, you still get the same thing. All right. Just get in the habit of putting them in order. All right. So whatever order they come in, that's the order you should write down. Just get in that habit because it'll just make your life easier. All right. So that's subtracting. All right. Let's talk multiplying. Multiplying functions. Who remembers a method for multiplying functions? So first off, maybe this might jog your memory. Let's just write it out first. So if you do f times g of x, I heard it. Who said it? You can FOIL. What's the other one? Box. So you can either do this through FOIL or box method. Now, my recommendation is if both your functions have 2 terms each, FOIL is probably one of your better ones. But if one of your functions or both of them have more than 2 terms, I highly recommend doing box method. All right, I'm going to do box method just for the sheer fact that g of x has 3 terms. All right, so when I rewrite this, I have 3x plus 2 times x squared minus 2x plus 10. The reason I'm not going to do FOIL for this, you can, it just gets dicey. All right, it's possible to do, but again, it gets dicey because what happens more often than not is someone forgets to, because remember, you got to distribute the 3x to all 3 terms. You got to distribute the 2x to all 3 terms, and then you have to combine my terms. What happens a lot is someone forgets the term. All right. Box method ensures that all your terms are accounted for when you're multiplying them. All right. So I'm going to make a box. So your box it's however many rows one of your functions are. So the first function's 2 terms, so I'm going to have 2 rows. I'm going to put a term per row, so 3x and then plus 2. And then across the top, however many terms you have, that's how many columns you have. So I have 3 terms in the second, so I'm going to have 3 columns. So, and I'm going to put a term per column, so x squared, negative 2x plus 10. My suggestion, get in the habit of just writing down the signs, even if it is a plus, because another big mistake I see a lot of times is people forget the negative. So if it has a sign next to it, just go ahead and write it down, just so you get in the habit. Now, who remembers how to do box method? How's it work?
Would you have 3x times x squared?
Right. So for every box, you would take the row that lines up with it and times it by the column that lines up with for every box. So for this first box, you're doing 3x times x squared. So you multiply the coefficients and then you multiply the exponents, which when you multiply exponents, what are you actually doing to them? Adding them. So what's 3 times 1? X times x squared? X cubed. Because remember, there's an unspoken 1 here. So you're doing 1 plus 2, which is 3. And then you just go down the line. So this next box lines up with 3x and negative 2x. So what's 3 times negative 2? Negative 6. What's x times x? X squared. The next box lines up with 3x and 10. So what's 3 times 10? 30. And then we still got the x, but there's nothing to multiply to it, so we just slap it on at the end. Next row, x squared and the 2. So what's 2 times x squared? 2. 2x squared. So there's no x on the 2. So all you're doing is multiplying the coefficients, slap on the x squared then. So technically we're doing 2 times 1 and then slap on the x squared. So what's 2 times negative 2 for the next one? Negative 4. And since the x doesn't have anything, we're just going to slap it on at the end. It's be negative 4x. And then lastly, the last one's an easy multiplication. There's no variables or anything. So it's 2 times 10? 20. Now, what you're going to do now is take everything out of your box and rewrite it in standard form. So I'm going to do 3x cubed minus 6x squared plus 2x squared plus 30x minus 4x plus 20. So I'm just taking everything out of my box. All right. Now, what's my next step from there? So I'm not quite done yet. What's the last thing I got to do? Combine the like terms. So my only like terms are my squareds and my x's. Ah, why? I will say some random stuff in this class. I promise you that. You haven't even heard the worst of it. Chase can probably attest to that. All right, so even if it's not highlighted, you still got to bring it down because that's part of your answer. So I'm going to bring down the 3x cubed. What's negative 6x plus 2x? Positive 4x or negative 4x? Negative 4x squared. 30x minus 4x? Positive 26x. And then you bring down the plus 20. And there's your answer. Now, again, to each their own. You could have definitely foiled that if you want. I don't care. All right? But, like I said, I highly do not recommend foiling for any function bigger than 2 terms. All right? So, for example, if we had like 3x times 2, 3x plus 2 times negative 2x plus 10, that would be a good foil. That's an easy foil. As soon as you add that third term, that's when it gets dicey. So it's not too bad when you have a 2 by 3. As soon as you get a 3 by 3, ooh, don't do it. Just don't do it to yourself. Just do box method. All right. I don't even want to touch foil with those. All right. Just because my brain specifically, I need that organization. I can't. All right. Doesn't mean that you probably can do it. Not saying you can't. Me personally, I can't do it. Don't wanna. Not gonna. All right. Okay. So we're gonna stop here for today. There is a new Delta math if you want to start that later. So if you have time, you should be able to do at least the adding, subtracting, and multiplying part. Well, no, I'll change the due date. I'll change the due date. I remember those are tentative. They have till. That's so you can go back and check. Because I'm not even great.
You got time.
Yeah. Now, it may start taking points off, but I'm grade based off completion. And I can see what you can do.
I did good.
Oh, guys, don't forget to erase your boards.